Verma Day. I work for NVIDIA and mainly manage the large language model product portfolio. We'll talk about a product NeMo framework and how to build large language models at scale. And then we focus on Azure with my friend Hugo from Microsoft. He's going to describe you and show you a demonstration. And I'm also joined by Shashank Verma and Vinh Nguyen, who work for NVIDIA, subject matter experts, solution architects, and they're going to help you answer any question. If you have questions, please feel free to write on the chat window. And once you do so, we'll try to answer your question as promptly as possible. We will try to finish the presentation in 15-20 minutes. And then, as soon as we are done, and if there are questions which needs, kind of read out, I will try to come on the mic and explain those answers to you. With that, with no further ado, given we have shorter time, let's go. Hugo, can you go to the next slide? So the NeMo framework is the framework which is produced by NVIDIA, which is a framework which helps to train large language model and deploy large language model in different environments across DGX on-prem, DGX cloud, that's DGX is our infrastructure name, and of course on Azure and other cloud providers. Here what you see is when you think about a large language model, you are thinking 5 things: data curation, foundation model training, fine-tuning, instruction tuning, customization, and deploying. All those are unique capabilities in each stages of a creation of a large language model. And NeMo framework does provide all these techniques as part of the NeMo framework. NeMo framework is available to you via NeMo framework open beta containers, and also NeMo framework is open sourced in the NVIDIA NeMo GitHub repository. So I'll take a few moments to describe each of these components. One of the critical components is data curation. All of you are familiar with, data curation takes most of the time. You start with terabytes and terabytes of data, and then you want to clean the data, and then you want to kind of blend the data to be ready. So a new tool we launched very recently. Please try it out, and we'd love to hear your feedback. Then look at the distributed training. This is where NVIDIA's lots of original experience and expertise comes along. And if you're training with multi-GPU, we do provide you recipes and we do provide you techniques. There is a tool we provide called hyperparameter auto configuration tool. You can understand what are the proper tensor parallel, pipeline parallel, and global batch size parameters you need to choose to achieve timely convergent models. The next technique or the next phase of large language model is the model customization. And the customization in this slide is used a little bit broadly, but originally it will be fine-tuning or supervised fine-tuning, followed by instruction tuning. A technique which is most popular these days is called RLHF, reinforcement learning with human feedback. That technique is also available in the latest NeMo framework. Once again, try it and we'll love to hear from you. And finally, the accelerated inference. Hugo, I do see the presentation. I see there's a comment. Folks say that they don't see the presentation. You can? Okay.
I see it as well. Is anyone else having issues? Nope. Lots of thumbs up. You're good to go.
Okay. So, Hugo, can you go back? Yeah, let's stay there. And then we do accelerated inference. So also, if you are training a 500 or you are running a 530 billion model, that takes about 64 GPUs to run. So how do you kind of deploy it across those GPUs and efficiently communicate all those instructions we do provide in our container? So not only we support text, Also, the latest container is supporting multi-modality. So besides text, we are supporting image, and we plan to support other multi-modalities. Hugo, can you go to the next slide? Thank you. So this is the on your left hand side, it talks about what are the architectures we are supporting. So for text side, it's GPT, it's T5, T5 MOE, and very large scale BART, like greater than 100 billion parameters. And we are continuously adding more and more, more and more model architectures. On your right hand side, we just released a container, NeMo multimodal early access containers. And in those containers, we support training, foundation training, and fine-tuning image models. We are supporting latent diffusion model, which is stable diffusion. And then we are also supporting discriminative image models like clip and swing clip. Beyond that, we do support image editing techniques like instruct pix to pix as well as dream booth. So all these techniques, from you see the philosophy, we not only we see that the foundation model training or fine tuning is important, but more and more lots of customers and users of this framework do ask us for these techniques where they can take a frozen model and they can enhance the frozen model with the data. That's why we spend a lot of energy and our resources to make those techniques available. Next slide. So, okay, now it's coming. All of you know kind of what are the challenges of large language model. I kind of alluded to those in the beginning, right? Mountains of training data. And that takes a huge amount of time to do those. So NeMo Data Curator is the tool. There is an article by MIT Press which says that about 100 billion plus model training takes about $10 million of compute. So you can imagine if you if your model is not converging, if you want to do 2 runs, 3 runs, probably you lost $3 million of compute. So you need a training framework such that which can help you to get to a model convergent model in right amount of time. These kind of things need deep technical expertise, and we try to provide as much guidance and documentation in our containers. Besides, it's actively supported by our team members, and complex algorithms, of course. So in the accelerated training, we do support 2 kinds of techniques. On the one is pipeline parallelism, basically is cutting the various GPU, various layers of the model in various GPUs, which helps you to increase the throughput. And the tensor parallelism, which is basically cutting the, one layer of the model into separate GPUs, so which helps you to optimize the latency. So a combination of pipeline parallelism and tensor parallelism gives you the proper, on the proper optimization, both on the throughput as well as the latency. Now, when we're doing that, this was trained with a very large GPUs, A180 gigs, and those kind of memory is not easy to come by. So we were hearing a lot of complaint. How do we can launch a technique? How we can make a technique available such that you can have, kind of memory optimization. So we launched 2 techniques last year: sequence parallelism and selective active recomputation. One is memory optimization and is memory consumption. And with this, we have seen there is about 29 to 31% improvement in the performance. So combination of tensor parallelism, pipeline parallelism, sequence parallelism, and selective active recomputation, you will get the most convergent model in the most optimal time. Next slide. Okay, but the frozen model, as we talked about, the frozen model is as good as when that was built. But the time changes, and you need to feed the model with your data. There are various ways to feed data into the model. One is, of course, supervised fine-tuning. We provide that technique in the container. One is instruction tuning. We provide that technique, RLHF, one of the very well optimized technique. And then also customization for smaller data set. We do support p-tuning, parameter efficient tuning with LoRa, parameter efficient tuning with IA3, adapters, and Alibi. In a nutshell, we are constantly looking into where the industry is going from a customization point of view, and we are adding more and more techniques. And latest, we are also supporting a technique called document retrieval or information retrieval. So if you're asking a question, what was the pressure of the pump at 11 p.m. last night? That kind of information was not available in the frozen model. That kind of information you can only, gather from informed kind of means document retrieval kind of technique. So we do support creation of retro model or informed model, as well as the framework does support this technique. And it not only provides you the answer, it provides you the citation where the answer came from. Next slide. So I'll go through this slide very quickly. Probably I indicated in the beginning that, not only we support training, we also support inference. So as I mentioned, when you are deploying at scale, as large as a model like 530 billion, you want to understand what is the tensor parallel, what is the pipeline parallel, what is the global batch size, such that if you can make the best out of your number of GPUs what you have, and we do provide that kind of information through our auto configuration tool. Next slide. And this is the last slide from my side. We launched NeMo Guardrails, which is a kind of, you can think about a much more guided dialogue management. Previously, who have been in the conversational AI / statistical NLP industry, you have to write a lot of spaghetti code to manage your all sorts of branching condition. But here, with this new technique, you can constrain the conversation, and it does not have to be purely rule based, because a large language model is working behind it, so it gains a lot of statistical knowledge. So you can make the large language model answer only topical questions. You can make sure it is age appropriate, it is your company appropriate, it does not give you kind of wrong answers, and it does not kind of provide any it does not it stops also prompt injection and that kind of technique. To give you an example, to make it real where guardrail works, let's say you are working with the NVIDIA HR bot and you are asking, okay, does NVIDIA support child adoption policy? It answers, so according to its knowledge, it may answer yes, it answers yes. And then the next question, if you can ask, okay, how many NVIDIA employees did adopt a child last year? That time, because that's a very private information to that company or to that database, so it says no, I'm not allowed to discuss about those kind of information. So that's a very kind of simple example, but you can constrain your dialogue a lot according to this new technique which is open source. Hugo, I believe that was my last slide, and so last thing the performance numbers, what you see, A100. So these are like trained with bfloat16 with 300 billion tokens, and you can see what are the performance numbers. These are like ideal runs. Means of course to make it more effective, you may need to do twice, thrice, but this is a kind of a directional guidance for you to look at, if you're doing a large language model training. And our latest generation H100 software, which is just coming out, which does 2.5x to 3x better than these numbers, but we will continue to share as we make that hardware public going forward. With that, thank you all. Once again, I'll come back on the other side after Hugo's presentation. Hugo, back to you.
Thank you. Hi, everyone. My name is Hugo Affaticati, and I'm a technical program manager on the AI and HPC benchmarking team. For today's session, I'll be explaining how to deploy and customize the large language model GPT-3 with NeMo framework on Azure. Prior to this demo, I deployed a cluster of two NDM A100 v4 virtual machines by using the orchestrating tool Azure CycleCloud. If you need more details about how to set up your cluster and test it, I invite you to watch the NeMo tutorial on Azure's YouTube channel. The first step of this demo is to download a dataset to train the model. To do so, I start by specifying the infrastructure we want to use for the preprocessing, the NDM v4 series, as I mentioned. Part of the customization of the models is to use the dataset that works for you. Today, I will be using a small dataset, only 2 shards of the pile from misting.di.eu. About the model now. We start by downloading and preparing the data by turning run data preparation to true. Every other flag should be set to false as this is the only step we want to run for now. Here, we are running a GPT-3 model, so run fine-tuning will remain false. But later on, one could turn run prompt learning to true if they want to customize their model with some tuning. Another part of the customization is the ability to use the storage adapted to the dataset. One could use some NVMe disks, some managed disks, a Lustre file system, etc. Thus, I am specifying here the path to my shared directory. Next, I am mounting a topology file specific to Azure for higher performance. Finally, I am using InfiniBand to benefit from the fastest communication method available between the nodes in my cluster. These three flags at the bottom of the screen will allow the best performance on Azure. I am using this command to download the data, but I will go into more details as we run the model. Within GPT-3 model, there are several variations available for you, depending on the number of parameters. I will be running the small 5 billion parameter model today for its rapidity. The script here is meant to use a dataset with 30 shards. As I mentioned, I am using 2 shards only for this session, but you can use as many files as you need and play with their respective weights. Since I have 2 files in my dataset, I am giving them an equal weight of 0.5 each. Back to our configuration file. We do not need to run the data preparation anymore, now that we have downloaded the dataset. So I will start by turning run data preparation to false. And then we'll be able to start training the model with run training equals true. The command to train the model has a few parameters. The main ones are the exact model, GPT-3 5 billion parameters here, and then the number of training steps, 200. This is enough to reach steady state and calculate the training speed. Although the parameters that have a direct influence on training large language models and that can be customized are the mini-batch size, the tensor parallelism, and the pipeline parallelism. The training of our large language model has now started. I am launching TensorBoard to visualize the results. Below, under the train step timing window, we currently see meaningless oscillations at the scale of 1/10 of a second. So we'll start by changing the scale. As I mentioned while starting the job, 200 steps are enough for me to measure the training speed, because the steady state is reached before the 20th step. Calculating the average of a few randomly selected steps at steady state gives a good indication of the time per global step. For example, step 149 took 37.5 seconds, step 159 took 37.51 seconds, and step 169 took 37.55 seconds. Thus, the average is 37.5 seconds per global step for the 5 billion parameter GPT-3 model on Azure. You have now successfully run a GPT-3 model of NeMo framework on Azure. As we published in October 2022, we tried up to 530 billion parameters on up to 1,400 GPUs. The graph that you see here highlights that the training time per global step is inverse proportional to the number of nodes. This means that customers can reach an almost linear scaling for the large language models on Azure. If you want to learn more about the parameters and the tests that we run on the platform, I invite you to follow the link aka.ms/ai/nemo. You can also find here many links to a lot more resources as you want to get started with NeMo framework on Azure. Thanks for attending this session, and we'll be happy to answer any questions that you may have.
Thank you, Hugo. I saw lots of questions. I think, lots of funny comments. Hugo, you got a compliment. You have to read your comment, but I think there is a few questions around the cost. So one of the things, we can say, because the cost will depend on how clean is your data set, how many times, you have, what are the model size, what is the tokens you're going to build. But from a NeMo framework point of view, I will answer it this way, and we publicly say that, and my marketing colleagues who are also in that call can share with you our blog with Korea Telecom. So Korea Telecom posted posted a blog and mentioned publicly that using NeMo framework, the training time was 2x faster. So if you're looking at a $10 to $12 million cost, so probably you are looking now at a much reduced $6 million if you just do the math. So answer to your question, why someone should use NeMo framework within our internal benchmarks, as well as probably the best way to share this is a customer testimonial that the customers find our training framework is 2x faster than what they have found outside or other options. The second question, another trending question, is about supporting external models. So, our philosophy is, as I was glad that Hugo was showing it to you through NeMo framework on Azure, the world's best large language models are .NeMo models. So that's kind of the philosophy or vision we try to kind of perpetuate, right? We hope that the adoption NeMo framework really goes that penetrative. Having said that, also we are looking to support very select community models, because this framework is used across the globe, and lots of customers outside of United States have some favorite model in the GPT or T5 architecture. We do not support all the models. Then our engineers will always be working with all those other models, but we do support very, very select. And if there is any particular interest of any specific model, you can. Now the follow-up question is, why do you need to do this? Kind of, if you take a Hugging Face model or what have you, and why do you need a framework and need to think about? Whenever you talk to enterprises, at least we talk to enterprise developers, researchers, there is never, I found, a single company which plans to use any model out of the box, right? So to kind of even customize or fine tune, instruction tune, you need a framework. You bring your own data and you kind of treat the frozen model with those kind of information. So that's where you kind of need. The question is, you need framework. Even you have a frozen model, either it's a .NeMo model or it's a community model we are supporting. Then we can be. You can go on your journey where you want to go with your data. So NeMo, Hugo, do you want to answer any question?
I'm going through this chat. I'm showing the resources now, because I see a few comments about getting resource data to get started.
Moderator, the question is, where will the slides be posted? Do we have an answer for the members here?
I will ask and get back to you guys. Just one moment.
Okay, we have answered how the reinforcement learning works, but if there is more interest, one of the things about reinforcement learning, the challenge in the reinforcement learning is providing stability. And you see lots of other offers provide 256 tokens. So what we are trying to solve is try to provide you more stability, try to provide the most performant RLHF technique. Our latest RLHF technique in the container uses one of our acceleration through faster transformer. So you are going to get all those benefits, and it does support much more than 256 tokens. So those are the kind of aims. That's kind of course, the framework itself supports, our current models have 5,000 tokens. So the framework supports that, and it is extending much beyond, like, you are seeing supports of 32,000, 50,000 tokens of models. We are definitely looking into that. But from RLHF, it's the stability and supporting supporting higher number of tokens is important. And besides that, traditional RLHF is you had a reward model, and with the reward model, you fine tune the supervised, the LLM model. But now you are going working on a PPO framework. Basically, your 4 models are working: agent, policy, actor, critique, and reward model. A combination of all this, you're going to get the best out of RLHF. All that is implemented, the performance, the higher token size in the PPO model, all that's implemented in this RLHF technique. Okay, so more questions I see on identified. What is the improve ongoing to ensure it's okay? Great. Great question. What we are doing NVIDIA as a company that about integrity, quality, and value? We discussed about guardrail, but that is after. But what we are doing during when we are producing when we are producing the large language model, I'll tell you 2 things. One is bias testing. So this product is being used across the globe, and the countries, you will be surprised, there are 40 countries we are working with who are trying to build their own ChatGPT. They call it sovereign ChatGPT, sovereign LLMs, and for them, sensitivity of the output is extremely important. So you want to ensure that the model does not have bias. So we are definitely ensuring that the model is going through a bias testing, and we plan to include those data sets and techniques as a part of the framework. And second part is about the toxicity. We are constantly improving the toxicity classifier. We have a different approach though. Lots of models do not provide the toxic information, but we have a little bit different approach. We do continuously improving the toxicity classifier, but we are providing you with the toxicity score. We generally do not like to filter any information because we do not want to judge what is right for you, what is right for your application. So you may deem something toxic where some other application may not deem it's toxic, right? So we are improving the toxicity classifier, and we are providing the toxicity score at every layer, and then you can decide what is the right for you. Okay. We have 2 minutes. Hugo, do you want to answer any other questions?
I see that most questions are NVIDIA related. I don't see a lot of questions for specific to Azure.
There was a question about Azure, is there a blog? Is there how they can get started on Azure, if you want to talk about that?
Sure. I think the first step would be to have a look at aka.ms/ai/nemo. It would be the page that will explain how we use the framework to deploy our clusters, to deploy our large language models. We've used a different variation of number of nodes, number of values for tensor parallelism, and mini batch size and all the other parameters, so you can find what works the best for you. And then I invite you to watch the complete tutorial on our Azure channel that will give you a step-by-step from turning on your cluster, testing it, to getting your data set and training on it. So start with aka.ms/ai/nemo.
Fantastic, Hugo. We are almost at the top of the hour. I appreciate all of you attended this brief session. There may be a lot of information we just presented. Please reach out to us. And also we want to thank Microsoft team on behalf of NVIDIA for helping us to present this session. Thank you all. We'll definitely talk to you later.
Thanks all of you.